Usually for maximization, minimization, you have two variables and then they are connected by one condition. This condition can be they are hypotenuse, it can be like the parameter, can be whatever lah, area or whatnot. Then you need to relate them. So if you look at the steps, right, for maximization, firstly, you identify the two variable, then the given condition, relate two of the variable, then your problem is basically to try and reduce the variable from two variables to one. Typically, that's the case. Then dy dx is 0 for stationary value. Then you have maximum and minimum for second derivative. Remember that. Okay. So let's try. So a parameter of an isosceles triangle. There's a triangle here. Isosceles. Okay. So this isosceles triangle, what it does is isosceles. So this is equilateral. Isosceles just means two equal sides. So isosceles here, the base length is x. The two equal sides here is y. Is 10 cm. Oh, the parameter is 10. So these are two variables, right? The two variables are x and y. So related by the parameter here. So the fixed condition is the parameter. So this is it. So we can relate them. So step number 1, you identify already. You relate them by using parameter. So it's x plus 2y equals to 10. Okay. So that when the area of a triangle is maximum, so area is maximum. dA dx or dA dy, it doesn't matter. Okay. But you can also use dA dy, not an issue. The maximum is where dA dx is equal to 0. And d square a dx square is less than 0. Okay. The triangle is equilateral. Okay, let's look at that. So area, if we just want to find the area here would be half times base times height, right? So the height here, if you think about it, the height here is just Pythagoras theorem. So the height square plus this one will be half x squared is equals to y squared. Okay, so that's why you relate both of them together. So this will be half of x. So this case here will be h squared equals to y squared minus 1/4 x squared. Height will be the positive one. You don't take the negative y. So this is it. You have to understand here. Oftentimes, whatever you want to find, right? It always comes in two variable form. Namely x and y, right? So what you need to do is just make it to one variable. So I think making a one variable easiest way would be y change to x. X change to y. X is equals to 10 minus 2y. Yeah. Maybe y better because I don't want to change the x outside. Oh yeah, y is better. That'll be then you just this is 2 square 4. There will be yeah. So I change it to one variable. So the next one is a squared minus b squared, right? So I will just do 1/4 x a squared plus b, a plus b a minus b. Now we know that we need to differentiate this with respect to x, right? Am I right? Okay. Then you can start differentiating, not an issue. You can do your secondary school way of differentiating. But the problem here is we don't really like this square root here. Anybody likes to differentiate square root? Can lah, you can do it lah, but it's not going to be very nice, right? So one of the trick that we use, because we already know implicit differentiation, is we're going to square both sides. Okay, we square both sides. Why? Because when we square both sides, we a square, this will be 5 over 4 x squared 5 minus x. Suddenly this one is easy to differentiate. Understand? Much easier. So if you have a squared equals to 5 over 4, you can put this as 5x squared minus x cubed. So you differentiate with respect to x. This one becomes 2a dA dx. 5 over 4. 10x minus 3x squared. Agree? So it's quite straightforward here. So you can differentiate once more because you want a second derivative later to show that it's a maximum. So 5 over 4. Later I label for you. So this will be u v, so it's u dv dx plus v du dx. Okay. As stationary value, you know that as stationary value, dA dx is 0. So you can just sub this as 0 here. So this case here will be 5 over 4 x squared. Because it is 0, so then okay. So this guy, this will be 0 ma, as stationary value. You already found this as 10 over 3. Area is always positive 1, confirm. Okay. So this case here, what you get is at stationary point 2a d squared a dx squared. Okay, so this one is less than 0 since a is positive. So thus a is x is 10 over 3. So y is then y is 10 minus x divided by 2. That will also be 10 over 3. Is it? You show that the length of x and y are the same, then they're equilateral. So for that will be area. I just use root 5 over 2x, right? Which is 10 over 3. 5 minus 10 over 3. Okay, then this will be root 5. 5 minus 10 over 3 will be 5 over 3. So that will be rationalize the denominator. Okay, that's it.